Hello everyone, my name is Naomi Bolden and today I'm going to be teaching you the science behind making milk chocolate. This recipe is right in time for Valentine's Day, so come along and maybe you'll be able to find a last minute gift. Now, you may be thinking, why milk chocolate? Milk chocolate is actually the most popular form of chocolate and the mildest. It contains milk, solids, and a large proportion of sugar, which together usually outweigh the combination of cacao solids and cacao butter. Thanks to its relatively low cacao butter content, milk chocolate tends to be softer and less snappy than bittersweet chocolate. So with that, let's get right into the ingredients and materials we're gonna need. For this recipe, you're gonna need cacao butter, milk powder, raw cacao powder, sea salt, powdered sugar, which is optional but will make your recipe taste even more tasty, a chocolate mold. I opted for the Valentine's Day theme, a double boiler, and a silicone spatula. The process of making chocolate is very complex. So, as I show you how to do it, I will also explain the scientific reactions taking place. Step 1. Melt your cacao butter in your double boiler. Begin by setting up your double boiler by adding a few inches of water to a medium saucepan. Bring the water to a gentle simmer over medium-low heat. We're going to allow our water to heat up for a bit, and during that process, I'll tell you a little bit about the science behind what's going on. As we wait for our butter to melt, I wanted to tell you a little bit about it. Cacao butter, also known as CB, is a vegetable fat, present in chocolate at levels up to 40%. Cacao butter is a complex compound containing various types of triglycerides. I'll give you an up-close view. The characteristics, physical properties of cacao butter are related to the arrangement of monosaturated and saturated fatty acids in the triglycerides. It leaves an oily texture on your finger like any other butter would. Now, like we just talked about, since it's so thick, sometimes you have to break it down with your fingers, which can be hard by itself. So you can get in there with a spoon if that's your choice. I'm gonna let mine break down a little bit more. But cacao butter is a fat separated from the cacao bean. Around 80% of the cacao bean cells are storage depots of protein and of fat, or cacao butter. Nutrients that will feed the seedlings as it generates and develops on the shady floor of the tropical forest. So what we're watching right now comes from those said forests, and we're gonna watch it melt. And while we wait, I'll tell you a little bit more about the cacao bean, where this whole process begins. Dry fermented cacao beans are less astringent and more flavorful than unfermented beans, but their flavor is still unbalanced and undeveloped, and often dominated by vinegary acetic acid. After selecting, sorting, and blending the dried beans, the chocolate manufacturer roasts them to develop their flavor. Whole beans take about 30 to 60 minutes at 250 degrees Fahrenheit. This is a gentle treatment thanks to the abundance of reactive amino acids and sugars that readily participate in the Millard browning to generate flavor. This invention called the double boiler was something new that I learned about during this experience of getting familiar with making milk chocolate from scratch. And it made me ask the question, and you're probably wondering as well, why a double boiler? So, the double boiler allows the chocolate to melt using even indirect heat. Since the water's not directly touching it, this technique is great when you want to cook or melt something gradually and gently. Rather than overwhelming the chocolate with the direct heat of a burner, this technique uses the steam from the boiling water as an indirect, even heat source. It will prevent the chocolate from overcooking or burning, and you give more control to the chef. Now we see that our larger pieces of cacao butter are still sticking around. Why aren't they melting down? It's because we have to break down larger pieces so that it will melt quickly. The science behind that is that when you chop up ingredients, it results in a faster melting time. This practice stands true in many other ingredients and materials due to the fact that with smaller surface area, the rate of heat transfer is greater, so the melting would be greater. Smaller objects have a smaller surface to volume ratio, so they melt faster. Now, we see that my stirring and my constant motion of it allows it to melt a little bit faster, but if I would have gotten in there and broken it down, then these big pieces would have melted just as fast as the smaller ones. Now I'm going to add in the remaining ingredients. And I forgot to mention it previously, but during this process, we're going to be using a sifter. I'll explain why. We're going to add in about 1.5 tablespoons of
Sifting breaks up any of the lumps in the cacao powder and adds air to it. Sifting also ensures the most accurate measuring. Taking a big spoon of cacao powder straight from the container, which is lumpy and packed down, likely has more volume than the recipe calls for.
And lastly, we're going to add in our dry milk. Now, once again, this is 1 tablespoon. And as you can see, you're not using too much of your ingredients, so you still have more time to make more. So now that we have a melted solution that looks like a chocolatey drizzle, step 3 is to grind the chocolate. Grind the particles within the chocolate into tiny microparticles until they are no longer discernible by the human tongue. For this, I will be using my Ninja smoothie maker. So I'm going to be pouring
Conching
it
is
into
also a
this
type of grinding.
Ninja smoothie.
However,
and then
it
we're
does
going
have some
to
differences.
blend it.
Unlike
That is
grinding, conching affects the flavor as well
as
as the texture of chocolate due to the addition of heat and air. It's a little bit like kneading dough to make bread. Cacao beans naturally contain acetic acid, which gives them a sharp acidic flavor. When the chocolate is spinning in the conch, it is heated and exposed to the air, which burns away the oxidizes the acid, giving the chocolate its rich rather than sour flavor. The last step of the process is to temper your mixture. This must be a controlled process because if you heat and cool chocolate without controlling the temperature, the crystallization will not be within the form that you want, meaning that it will appear matte and covered with white patches. It will also crumble rather than snap. Cacao butter can crystallize in any of the 6 polymorphs. Unfortunately, only one of these, the beta crystal, also known as Form 5, hardens into the firm, shiny chocolate that cooks one. Our goal is to have the chocolate form into those
a little bit more easier, I'm going to take
when the chocolate solidifies, these fat molecules line up into the ordered crystals. As the chocolate cools, these invisible small crystals grow until they touch each other.
Now let's take a journey right on over to the freezer.
Chocolate has one of the richest and most complex flavors of any food. In addition to its slight acidity, pronounced bitterness and astringency, and the sweetness of its added sugars, chemists have detected more than 600 different kinds of volatile molecules in chocolate. Thank you so much for joining me in this chocolatey experience.